Thank you everybody for joining. My name is Oscar Romero. I am a product specialist and owner at a company called CAD/CAM Pilot, and we're an Autodesk learning partner, which means we get to come and do these types of workshops for students and educators throughout the United States. Today, we're going to be focusing on Fusion simulation, as you see there. I'm going to go through an overview of what Fusion 360 is in its totality, just as an introduction for those of you that are new to Fusion and or new to CAD overall. So let me go and get started with that. Again, a little bit more of an introduction about myself. And I like to do this just to make sure that people understand who's talking, what kind of expertise is behind the person who's talking, and so forth. So that's me. I won't have my camera on during the presentation, but that's me in the picture. Before opening CAD/CAM Pilot, we did have a lot of industry experience. So you can tell here now we're a certified instructor at the gold level, an ALP, Autodesk Learning Partner, Fusion 360 reseller, and an Autodesk authorized training center. However, we built on that previously, being directly employed by Autodesk and Delcam as an applications engineer, dealing with a lot of technical sales cases, right? So we were mostly dealing with industry customers that are actually making things that go into the world. We're training those customers in software for CAD and CAM and doing a lot of customer support, right? So we're supporting customers in industry as well as education and potential customers coming into that side of the business. Before that, I count on about 30 years of design and manufacturing experience in the aerospace, automotive, industrial lighting, and the tooling industry, amongst a few others. So I've got a pretty well-rounded view of what manufacturing looks like and what design looks like when we're talking about different industries. Right, so enough about me. Let's talk about what Fusion 360 is really quickly. And if you're not aware of what Fusion 360 is, it's a CAD CAM software, but it's a little bit more than that. It really takes you through the entire cycle of the concept to design to simulation to manufacturing and so forth. So it's an integrated platform that allows you to do multiple things with the same data instead of having disconnected data. And this is kind of just a bit of a graphic of what that might look like, where we iterate a design and we take it all the way through the CAD design, the simulation, the manufacturing, and all the way around the entire cycle. The different types of CAD capabilities that are in Fusion 360 currently are various, right? So some software out there have what's called parametric design. I won't name any of them just to focus on what Fusion is now, but parametric design is something that basically you take a sketch, a two-dimensional sketch, and you add dimensions and features to it, like circles and lines, and then possibly constraints, and then extrude that two-dimensional shape into what a 3D model might look like. And Fusion 360 has that, but it also has other things like freeform design, where you can actually create some pretty exotic and complex surfaces, like you see there on the top left corner of the graphic. We have mesh design, which you can actually import meshes, you can measure and modify meshes, fill holes, make corrections, and other things like that. There's sheet metal design for just flat two-dimensional sheet metal, or 2.5-dimensional sheet metal, that you can create three-dimensional designs for, do things like bending, relief bending, and so forth. We have surface type CAD, which is the traditional type surfacing. And then we have direct modeling, where you can actually take a CAD model that wasn't actually designed in Fusion 360, import it using the AnyCAD tool, and still continue to modify it, right? So you can import CAD data that's not native to Fusion, and you can do things like remove holes or even add holes. You can extend extruded surfaces, delete faces, and other things like that. So, besides the CAD side, we have what we're going to focus on today, which is simulation. There's a lot in simulation. We'll go through a portion of it, and then we'll describe the rest verbally, and so you can get a good idea of what simulation consists of in Fusion 360. Basically, what you can do in simulation is take your model and simulate events like static stress analysis, or structural buckling, event tests like drop tests, thermal heat tests, and so forth, to make sure that your design, when you're creating it in CAD, you can simulate those events and virtually test them to make sure that they're going to perform as you intended in the real world. So we'll get to that in a bit. Um, the great thing about simulation, by the way, is that it is easy to use. So in a lot of other software that are specific to simulation or that have simulation tools within them, they're very complex to actually understand and apply the different settings into. And Fusion 360 attempts to make that workflow a lot easier, giving you a simple interface, simple tools, but very, very powerful technology in the background to actually give you realistic outcomes to your simulations. Another thing in Fusion 360 is the ability to create tool paths for your manufacturing uh, designs, right? So if you're taking a CAD model and you happen to have access to a 3D printer, a laser cutter, a water jet cutter, a CNC machine, whether it's turning or milling, you can create tool paths that are going to drive that machine directly from the model that you've created in CAD. The great thing about this is that the CAM side is model aware. And so if you make changes after you've created tool paths to your CAD design, those changes are going to be noted. They're going to flow into the manufacturing side, and you'll get either updated tool paths to your new design, or you'll get the opportunity to update the tool paths manually to reflect your new changes in the design. As I mentioned, you can create 3D printing tool paths within Fusion 360. Basically, what you have is an onboard slicer for your 3D printers. It comes complete with post processors for a majority of 3D printers that are out there now available in the market, and the most popular ones are obviously in there. There are some that may not be, but I don't think we've run across any that we haven't been able to create 3D toolpath for education. So that's a benefit there. We do have electronic design in Fusion 360 as well. So you can create your 2D layouts of PCBs, and you can actually create 3D PCBs as well. So once you're going in designing your layout for your PCB and you're applying components that go to those layouts, Fusion 360 has a large variety of components, libraries that you can apply to your electronic designs. Those are both two-dimensional descriptions as well as three-dimensional CAD models. So you don't have to redesign your CAD models for your PCB. You can just basically describe them in your 2D layout and create the 3D PCB as you see there in the center. And the great thing about this is that because Fusion 360 holds all of the data, you can also integrate those electronics designs into your CAD designs, right? So if you're creating some kind of enclosure for your electronics, that would be a mechanical design. Once you create your electronic design, you can bring that over as a 3D model, fit it into your enclosure, make modifications if you need to, on both sides, on the electronic side or the mechanical side, as you're designing. This is one that I believe we've done here before. Fusion 360 Generative Design. And generative design is a tool that allows designers and engineers to come up with designs that they might not have been able to come up with on their own for various reasons, either expertise in certain areas or time constraints or other things like that. Also comes up with some very unique designs and solutions to problems that the designer or engineer might not have thought of. And it does it with calculations in the cloud. So it's very fast, it's very efficient. A lot of people use it for things like lightweighting or strengthening and areas where the design might need it according to your constraints. Fusion 360 also has documentation. So as you're going through your design, you may need to make documentation for either a presentation, your engineering presentation, or for manufacturing. If you're actually going to send this out to be manufactured, the manufacturer needs to understand what components go to your design, how they interact with each other, and possibly even dimensions so that they can create your design into real life. So you can create two-dimensional drawings of all your components within Fusion 360, again, with all the data connected. Because Fusion 360 is a cloud platform and it holds the data to your entire design all the way through the cycles, it also allows you to collaborate with other users, whether they're using Fusion 360 or not, right? So if the collaborator happens to be using either another software, no software at all, maybe they're just in a managerial position, or maybe they're a supplier, you can still interact with them using a web interface, right? So that's for people that are not using Fusion 360 and you'd like to share your design with them for whatever purposes, you can still send them a quick email, an invitation to your project. They're able to see your model. They're able to see your tool paths if they happen to be in CAM. And they can input things like messages to give you feedback on your design. If the other person that you're collaborating with is using Fusion 360, you can actually send them an invitation to collaborate with you on your project, and they have direct access to the same data that you have, not copies of the data, not anything that was emailed in a zip file or sent through Dropbox or other things like that, where the data would be disconnected if they were to modify it on that side, on their side. So it's a truly 360 degree access to collaboration tools in Fusion 360. Again, because Fusion 360 is a cloud platform, you have accessibility on your desktop, on your laptop, on mobile devices, or even tablets. Anywhere you have an internet connection, you're able to access your data. There's another thing that Fusion 360 really has great advantage as opposed to other software. It is capable of running in Windows operating system as well as Mac, and you can even run it on a browser, right? So if you needed to be on a device that doesn't actually have processing power enough, computing power to run, say, some of your simulations or your toolpaths, you can actually access it through the browser. It basically runs as a virtual machine, and you can have all the tools that you would have in Fusion 360 interface. That's the presentation as far as what Fusion 360 is. Some of the tools that it has, kind of a broad perspective of what that looks like. Again, we're focusing on Fusion 360 simulation today. And I apologize. I keep saying Fusion 360. The name has recently changed to Fusion. They dropped the 360. It's now Fusion. It's a platform. So let's go ahead and I'm going to step out of this and I'm going to go back to my Fusion. I'll share my Fusion screen. And hopefully we get no interruptions as far as boxes go here. Yeah, we're good. Okay. I currently have a model in here. I'm going to go ahead and let me go ahead and close this down so I can start from the very beginning. That's the model we're going to be using for the simulation. It's accessible to you within Fusion. It comes loaded with some of the examples for a simulation, and I'll show you where you can get it now. So this is the Fusion 360 or Fusion interface. There's a lot that we haven't gone through. If you haven't used Fusion before, I'll just run you through really quickly where you can find some things. At the very top here, this is your toolbar. Across the top, there's several tabs that you can actually click on. It'll show you different functionality depending on the described tab. So for us, we're going to stick in the solid tab for now. This gives us all the solid construction tools when we're in the design workspace. Now, if we're in another workspace, say generative design, rendering, animation, simulation, manufacturing, or drawing, that toolbar or set of toolbars will change. And you can switch back and forth between those workspaces, again, using the same data. So if I have a design, we'll show you here in a little bit, I'll bring in a design and I'll go to simulation. My design will still be there, but I'll have different tools specific to simulation. So now I'm going to go and show you a little bit about where you can find the CAD model that we're going to use. You can use any CAD model that you create, but for this purposes of this demonstration, I'm going to go to the data panel. And typically you'll just wind up at the top of your data panel with any projects that you've pre-created already. These are mine. And as I scroll down, I get to the point where we have all of our libraries as well as our samples. The sample section that I'm looking for is almost at the bottom here. It's called Simulation Samples. And if I double click on that, it'll reveal several different folders with examples. Now, I want to look at the hands-on exercise folder, so I'll double click there. And then there's several examples here that I can use just for testing Fusion simulation, and also for doing workshops like this and giving examples of how simulation might work. The model that I'm going to use is towards the bottom here. It's called Support Beam, and I'll just double click to open it. It'll come into my workspace, to my canvas here. And this is what you saw when I first opened Fusion. I'm going to go ahead and hide away my data panel so I get a little bit more real estate when I'm looking at the workspace. Now, this is kind of a cross beam here. It's a bit of a complex model in the respect that it has several sections in it, and it could, depending on the complexity of the model, it could take longer to simulate than a simpler model. We're going to go and try this. Hopefully, and I haven't tested this one before, we'll be doing it live for the first time. But we'll go ahead and see what the time calculation is for simulating. There's two types of simulation calculation in Fusion. There's either a in computer, which is basically whatever your computer has for processor, for memory, for graphics. That's what it'll use to process the simulation. And the other one is going through the cloud. Now, if you go through the cloud, it's going to send your simulation up to the cloud. It's going to calculate using pretty much limitless computing power, depending on how many people are using simulation at the same time within the ecosystem. But it usually comes back pretty quick. And it deals with larger, more complex models better than what your computer might. So that being said, we're still in the design workspace. And what I want to do to create a simulation event for this, for testing this crossbeam here, is I want to go to my workspace selector, click it, and then select simulation from my options. Okay, once I do that, I get a dialog box here that asks me basically what type of simulation do I want to create. The very first one there is static stress. That's actually the one we're going to create today. However, there is multiple options. This has grown over time to include more options for you to simulate. You can do things like modal frequency. You can do electronics cooling or thermal simulation, thermal and stress simulation combined. You can do structural buckling, nonlinear static stress testing, quasi-static event, and a few others here. Dynamic event simulation, shape optimization, and injection mold simulation. I do have to make a note here that because you have an educational license, some of the options that you see here in my industrial license may not be accessible, right? You may have, with an education license, you may have a limited amount of events that you can produce. Um, so this injection molding one may not be available, and the quasi-static event simulation may not be available as well. That's a limitation of the education license. This may have changed since the last time I used it, but just be aware that you may not have all the options that you see here. You will, however, have absolutely you'll have access to static stress and thermal and structural buckling for sure. And that's why we're going to use static stress today. It's the one that everybody has access to. We'll go ahead and select that. To give you a little bit further a description of what each one of these options may be, you want to look at the right-hand screen here. This is labeled per option, right? So currently I have static stress selected, but if I go to modal frequency, this will change and it'll give me a different description of what that type of simulation will do for me. So if you're looking for something very specific and you're not sure what to select, make sure you go through and select each one, read the description of what the simulation is going to do for you, and then decide from there. Okay. So again, going back to static stress analysis. One thing I didn't mention here at the bottom is help me choose a study type. This will, if you click on it, it'll give you a little bit more help on deciding which one you want to select. So once I have my option selected, I'll go ahead and say create study, click on that. And you'll notice that first my toolbars appear for simulation, but also the browser section of Fusion gives me a little bit of a different look. It, by default, it creates a study for me. So all of the options that come with that study are also listed below it. Material type, load cases, any contacts, the mesh, which is very important, and then finally results. Some of these options are correlated with what you see in the toolbar that's up here. It's not always that in this case, in anyways, in simulation that you're going from left to right. Sometimes you're picking things kind of 2 or 3 options to the right and then coming back. This kind of differs from maybe the design workflow or the or manufacturing workflow. But we will go through each of these steps together. So apologize there. I had to pause. There's a very loud siren going by my window here. Okay, we're going to go and get back into it. I was talking about the toolbars versus the browser and then the options for each of those. I'll start with the description of what the toolbar actually has. Right at the beginning there, you have the option to select the study button. That will basically create another study because you can create multiple studies and actually simulate them as well at the same time. So for instance, if you were to create multiple studies, one for a certain load, or another for different types of material, different sections that are being held as constraints, other things like that. You can actually create multiple studies within the browser here and then send them up to the cloud so you can generate them at the same time. And also, the benefit of that is being able to come back into Fusion and continue working, say, in the design workspace or something else, while the cloud is calculating your simulations. So you can, just selecting the drop-down menu is only going to give you one option. That's kind of just really there for expanding the menu in the future. But you really have one option there, just create a new study. We'll go and duplicate a study as well later on. We'll show you how to do that, so you don't have to re-input all of your data if you just want to change 1 or 2 things. There is a simplify option here. And this simplify option, when you select it, it comes up with this mini CAD editing tool. And what this is meant to do is to help you simplify your CAD model so that you're not calculating small features that are not really important to your design and maybe not affect the entire simulation event in the first place. Things like radiuses that are small, maybe on the edges of the flat surfaces that are just maybe meant to break the edge so that it's not sharp. Or if you want to remove faces or holes, you can do that by selecting this modify and then do things like, again, remove features, faces. You can press and pull. Uh, you can do some pretty complex things here if you wanted to, like shelling. However, it's probably not recommended if you're intending to simulate your design as realistic as it was first designed. So, anyways, once you're done with this modification tool, all you have to do is click on this Finish Simplify, and then it comes back to the simulation toolbar. Okay, I didn't make any changes or edits to my model, so I'm good with that. The next thing is to choose a material, right? So you want to choose a study material. A lot of times when you create a model, you'll apply the material type to it, so it's already there. However, that's not always the case. So we want to go and either click materials here, or within the browser, we can select this edit button to apply a material. Right? Either way, you get a little dialog box here. Let me make sure it's fully in view. Yep. So you'll get the dialog here that allows you to go and select from all materials, materials with invalid properties or materials with overrides. I'll leave it in all materials. You can select the material library that you want to choose from. I'll select all libraries. And then here in the list of components, we only have one. It's called Beam 1. You have the study material type. Now you can leave it as the same as the model. If you applied a material when you were creating the CAD model in the design workspace, or you can go to this little edit button. A drop-down menu will appear. When you select it, you'll have access to all of the types of materials that are in the current libraries. For me, I want to make sure I choose a steel, and we'll get in there. You can also search, by the way. There's a search bar up there. Let me get down to steels. We're just going to pick a plain steel, right? And select OK. There's a few other things when you use the drop-down menu here in materials. You have material properties. You can manage physical materials. So if you want to add or subtract or um, other things like that to your list of properties and materials, you can do so. And then you can display study materials in multiple colors. Right. So once you've applied your material, the next option is to apply constraints. You need to tell Fusion 360 where this component is being held from, whether it's bolts that are holding it. You may want to choose the bolt hole area. In this case, we don't have bolts, but we can imagine that at each end it may be being held either by a weldment of some type. Um, it may be that it's being held at the very bottom there at each end. I'm going to choose each end on the flat face side. So when I select my structural constraints, I get this little dialog box here that allows me to choose from different types of constraints. When I click on that drop-down menu, I get 5 options. I get fixed, pin, frictionless, uh, prescribed displacement, or remote. And the very first 3 there are probably the most popular. Fixed is basically what it sounds like. You're just telling Fusion 360 that whichever faces or features you select are going to be fixed in space. They're not going to move. There's not going to be any movement to them. Again, this could be in areas where it's the components being welded, held by a clamp or bolts or something like that. If you have a pin, there may be say a circular pin holding up the component, but it's also able to rotate about the pin center. Okay. And then if you have frictionless, basically you have Sometimes you may have a component that is leaning up against the wall, but not actually anchored to the wall. Or maybe it is anchored to the wall, but you need to define that the wall is there. You can create a frictionless type of structural constraint and select the face that's contacting the wall. When you use that, by the way, the if that's the only constraint that's applied, your component has the capability of moving across the wall that or the face that has been selected. Okay. Again, I'm going to choose fixed here for ours. The other things here is the next thing it asks us for is the target. So the target is basically where it's being fixed. And I'll choose this face here as well as the other end here. Okay, so I have two faces selected, and I can apply the axes where the fixed constraint is going to be held to. So in my case, it's going to be held in all three axes, X, Y, and Z. So I'm not going to click on any of those. If I did click on them, they would actually be taken away. So I want to go ahead and make sure that all of them are selected. I'll say OK. And then constraints has a couple of other options. The bolt connector actually allows you to kind of mimic what a bolt might do when it's holding on to the component. And then a rigid body connector would do the same, but only with a rigid body. Now, the other option here is to apply loads, right? So we know where the component's being held at. We know what type of material it is at this point. Now, where is the structural load being applied, and how is it being applied? A few options here for the sake of this workshop and to make sure that there's no confusion. I'm just going to choose that first one there. We'll come back and talk about the rest in a bit. And we'll select structural load. Again, a small dialog box comes up with a drop-down menu that allows you to use the type of force that you want to apply to this component. It could be force, pressure, a moment, a bearing load, a remote force, hydrostatic pressure, and or remote movement. Now, this may just take a little bit more on your side researching what types of forces you may want to apply for your component. For us, we're just going to choose the force type, and we'll select the target. Now, I want to apply some force here to the center face, and when I click on that face, you can see the arrows that pop up here, basically indicating the direction of the force. There's also a small entry field that correlates with the magnitude entry field on the dialog box. In the dialog box, you don't have the drop-down menu, but here in the entry field that you see above or over the blue arrows, you do have a drop-down menu that allows you to change the type of force that you're applying, right? So you can type in the amount of force that you want here or here. If you need to change the units of the force that you're applying, you can click on this paper ruler icon, and that will reveal a drop-down menu that will allow you to change through the different types of units. So for me, I'm going to type in, let's go with 1,000 on this one, 1,000 units of force. There's also a few other things here in the dialog box that allow you to change things like the direction of the force. There is angle of force, and then there's also vectors if you want to use vectors. This one's going normal to the face, so directly down, in this case, because the arrows are pointing down onto the face, right? So I'll select OK here, and we'll come back and choose something different here in a little bit to show the difference in types of constraints and directions, and so forth. Contacts. So if there are any contacts that are happening within your simulation, you can select them here. You can do automatic contacts and manual contacts. We only have one component here. This is usually when you have some type of assembly with multiple components that may interact with each other during a simulation. And so I'm not going to choose anything here because we only have one component, right? Now, one very important thing here is that simulation does not work just solely with your parametric CAD model. It needs to have some kind of a mesh to apply the simulation to. This, by default, by the way, in Fusion 360 in the background, there is a mesh that kind of makes up the CAD model. The tightness of that mesh, however, needs to be manipulated for optimizing your simulation. If you notice here, there is some mesh settings that you can display. But here in the mesh, in the browser, you can edit the mesh itself. So if you select the little pencil icon, a dialog box comes up here that allows you to go ahead and apply a mesh and modify it, the fineness of the mesh. There's two options. There's a model-based option, and then there's absolute size as well if you want to give your mesh a specific size. And what I mean by that is the rectangles and the triangles that make up the model, and we'll see it here in a little bit. That's what we're going to have to modify to get the optimal analysis here. So in model-based size, I'm going to go ahead and leave it at 10%. I'm going to say OK. And then I'm going to right-click over the mesh in our browser and then click on Generate Mesh. So it'll go through a generation of a mesh for my component here, and you'll see it pop up here in a bit. Again, the fineness of the mesh matters for accurate simulation. You want a fine mesh in areas that are small, especially. So, for instance, on the top face here, if we have, say, about 4 rows of rectangles, for instance, this would count as a rectangle, 2 triangles put together. And then the next one, it looks like the top face would be suitable. So we want about 4 rows of rectangles, right? But on the side faces, seems like we only have 1 row going across of rectangles. So in order to get a good simulation for this, I would want to refine my mesh to make the triangles and the rectangles small enough to be able to fit 4 rows within that area. So let me go back and edit my mesh a bit. I'm not really sure what size that smaller face is, but I'm going to choose absolute, and I can choose a size. So 10 millimeter, I'll go ahead and go with what the default is in there. And of course, when I make a change to my mesh that's already been generated, I get this little icon telling me that it's out of date, a little highlighted. So I can go ahead and right click again, generate the mesh, and go through basically the same process of generating the mesh. Now, actually, it looks like a better mesh when I pick an absolute number, but I still have only 1 row going across those smaller faces. So I want to tighten that up. That 10 millimeters just wasn't enough. Let's go and change that to 2.5 millimeters and say OK, and then regenerate our mesh. Now, as we're going through this mesh, notice it is taking a little bit longer. So if you raise the number of, sorry, if you make your mesh segment smaller, like I just did, just know that calculation is going to take just a bit more. Again, going back to the complexity of the initial model is also going to have an effect. If it's a relatively simple model, you shouldn't see that much of a lag. But if your design is complex, or at least as complex as this one is, it'll take a little bit longer to create a mesh for you. Okay, so it looks like it created a mesh here. Now we have a really fine mesh. This is a relatively large component, and so there's a lot of mesh here. There's a lot of triangles making up the mesh. If we zoom out and we kind of look at it, all of the flat faces now have a mesh covering the entire thing. Now, what I wanted to get to is on these side flat faces, having at least 3 or 4 rows of rectangles, and I think we've achieved at least 3. So we're going to go with that for the sake of this workshop. Right on. Okay. Um, now that we've created a mesh that seems like it's going to work for us, I'll go ahead and go to the next step, right? So display, we can't have the model view or the mesh view. I chose the mesh view here. That'll do it for me. That's why we're seeing the mesh there. Now, there is one icon I want to draw your attention to. This pre-check icon. It's important to go through the steps that we've just gone through, selecting the model, selecting the material for the model, adding constraints, loads, and generating the mesh. Those are the major steps that we need to create some kind of simulation. Once we've achieved enough of the steps to create a simulation, we should get a green check mark here saying that it's the component has enough information to solve the simulation. If we see a red or an orange in this button, that means that we're missing something, right? We may be missing a constraint or a load or material type or even generating the mesh. So make sure you have a check mark there, a green check mark on this icon for pre-check. Now, it seems I have enough information, so I'm going to go ahead and select the solve button. When I do that, I get the Cloud Solver dialog box. Now, I only have one study created here, so you can see there's one study named there. It's study one, static stress, simulation mode one. I have the option to show all the studies with errors or only solved studies. If I had multiple studies that I wanted to go and generate at the same time, they would be listed here if they were created, and I can check or uncheck them based on what my decision is for actually running those into simulation. Now, in the industry side of Fusion 360, industry customers have to pay for simulation as an option, right? So they either pay some kind of cloud credits or they pay a monthly or a yearly fee to be able to use this technology. If they're using some type of cloud credit, each of the simulations actually costs them money. It doesn't cost them money if the simulation fails, but it does if it's successful and it goes through. Now, for students and educators, you have this technology for free. You can run as many simulations as you want, and you won't be charged for them. You just have to make sure that simulation is active in your extensions. I'll go ahead and run this simulation, and then I'm going to show you where you can find, if you don't have simulation available to you, where you can turn it on. So if I go and click that start, I'm actually going to save it. Let's see now. Yeah, we'll just go with that. Okay, so it gives me a second dialog box. Now this will stay active until I close it. And even then, it'll stay active in the background. Just getting a little message here that I need to make sure that my network is safe. Right, so it's running a job. It's giving me that uh, message saying that there's a current cloud job active and running. It gives me the status bar here. It's about 7%. Again, this is a pretty complex design, so we'll go ahead and make sure that we get through that. Hopefully we get through it before the end of the workshop here, but I'll go ahead and close. And I want to show you where you can open this extension if you do not have it. Now, in the top right-hand corner of your screen, you have this little little plug button right next to the clock. If you click on it, you'll get the extensions dialog box. And for me, again, because I have a non-resale license through Autodesk, I get access to all of the extensions except for the signal integrity for electronics. However, if you look all the way to the right, you have a simulation there. Mine is active. If yours is not, you want to go ahead and activate it. You go through the process. It's basically selecting it and saying that you want to activate it. It'll go through and it'll turn on. A lot of times with the educational license, what will happen is that you'll get access to these tools and the extensions for about a month at a time. And after that month of being active, it may go back into non-active, right? So if you ever lose access in your educational mode to any of these extensions, including simulation, come back in here and reactivate it. And you should be good to go from that point. So you'll just have to reactivate it if you lose access for some point, at some point, sorry. Right. So my simulation is still going. I can click on my little notification center here and then select the scheduled cloud job. Looks like it started already. Let's go ahead and check that off. And then I should be able to view it again. Here we go. Now it's in progress. It looks like it may be giving me, I don't see the progress bar here anymore, but it may be giving me results here in a little bit. And we'll talk through what the results might look like once the study is complete. I'll pause here for a second. If anybody has any questions, feel free to go ahead and open your mic or type in the chat, and then I'll be glad to go and answer those. Right, so it doesn't look like we have any questions so far, but again, feel free to go ahead and ask, open your mic or type in the chat if you have any questions on what we've gone over so far. I'm going to go and close this simulation. It looks like, oh, there we go. We got to solve. Right on. Okay, so we got a green check mark on our browser. I'm going to go and close this window. Right. Now that I know this is solved, the solve is complete, I can use some of my other tools to actually go ahead and see my results, right? So at the end there, I have a drop-down menu for, again, results, so I can just click the button. And what happens here is I get a whole new toolbar as well as the results bar over on the right-hand side, lower right-hand side of my screen. There's a lot here, and this is really meant to give you tools to be able to do things like simulate the event and measure safety factor as well, right? So this is actually a pretty well-built component. You can see there is an outline of where original component edges were at, including the holes at the center, and where the displacement was at, right? So there's a lot of displacement here. How can we see areas that are being affected more? Now, over on the right-hand side, we can see areas that might be in either red, yellow, green, or blue. Blue are the safe areas, things that did not break. They might have buckled but didn't break. Any areas in green, yellow, or red were affected drastically and might need to, for instance, either be accounted for in the design or maybe even modify the design to work things out a little bit better. Also, keep in mind that we applied a certain load onto this component. And so if we're okay with either changing that load, maybe making it less, or possibly making it more, to see what the limits are of this component before it actually breaks, we can do that. We can make that modification. Now, there is a couple of things here. We have load case one. We can choose from the different load cases if we had them. We only have one, so there's only one there. We can choose from safety factor. In this case, we're seeing what the safety factor is, but we can also switch to stress. And that's going to give us a whole different view of where the stresses are happening in our component with the simulation, right? According to where we constrained it, according to where we applied and how much force we applied to this component. We also have displacement here, so we can see where the component is most displacing from again, the green to the red, I'm sorry, blue to the red. Now, if we use our little slider bars, we can actually hover over these arrows and go through and eliminate where it might be safest and just focus on areas that might be more out of the safety factor. I'm sorry, in this case, displacement. And we can do that on either end. We want to see the safest and the least displacement. We can do that as well. There's also a few others, reaction force, strain, and contact force that you can choose from. You can choose the total in different vectors, so X, Y, Z. You can also change the units here as well for displacement. A couple of things there with respect to settings. You have some of the same tools here on the toolbar, by the way, results tools, but you also have others that you can use to say simulate your event, right? So if I choose animate here, I'll get an additional little dialog box here that allow me to play through the simulation. And it by default, it's in one way, but we can choose two-way and have it loop. So we can see it go back and forth, just so that we can see the simulation of the event. We can also change things like the speed, so we can make it a little bit faster. The steps here are the actual steps that the simulation is taking, sort of like frame rates in a video or simulation like that. So it's kind of choppy with 10. Let's go to 20 here, and we'll reduce the speed so we can see a little bit better. Oh, looks like I typed in 2 and not 20. So now with 20, we get a smoother transition from one step to the next, right? And then the higher amount of steps that we have, the smoother it's going to be. But basically, this is just visualizing in this case, the displacement of this component with the forces applied. Okay, great. Looks like we have a few that are dropping out because you have to go either to classes or you have something else. That's fine. This is being recorded, so you can watch it later if you'd like. Right. So I mentioned that we'd have a bit of a shorter workshop today just because it looks like we can get through most of it. I know you all are busy, and we can get through the workflow like we just did, at least for one of these events, in about an hour. So we managed to do that. The 6 major steps there of doing things like having a model, creating constraints, selecting material, selecting the force and the direction, all that, as well as generating your mesh. Those are the major components here to creating simulation. And they're a little bit different for the other types of simulations, depending on what they are. But this is one of the more common ones. So we use this as an example. Now, there are a few other tools here you can use compare to compare one simulation over the other. In other words, one study against another one. You have things like deformation, underformation. You can toggle the display of the mesh. You can manage your load cases if you have multiples here. And you can do things like inspect and showing matrix, surface probes if you'd like to check displacement there as well, and so forth. Now, when I'm done with viewing the results here, I can just go ahead and select finish results, and I'm good to go. Now, with respect to loads here, if I do have a load that I want to go ahead and modify, maybe I want the load to be applied in a different area, maybe I want to apply it in a different angle. I can choose my load case here, expand the menu, select loads, right click, and you should be able to open up your loads section again. If I right click and select load case attributes, you can see there all the attributes for the load. If I expand the loads menu, I get the option to either check it on or off and then edit it as well. If I edit it, I get the edit structural load back and I can do different things. I can apply a different load force. I can change the load type. I can change the angle. In this case, if I select that angle, I get two things here. I get the ability to go ahead and rotate the angle of which in which the load is being applied. Excuse me. So, but I also get the ability to go and change where the load is being applied. If I choose that little target button, I can move it. It looks like it moved the face there. Excuse me. Apologize. Had a bit of a coughing spell there. Now I want to make sure that if I get this, what I'm doing here is I'm clicking on several sections. And I actually want to get rid of everything except for the top face that I wanted. For some reason, I'm not able to select them all. So I'll just click clear here and reapply that top face. And then I can move my target and my angle. Say okay. Again, my results are tainted there, so I have to rerun my simulation. I can send it back to solve, and this may be a little bit more. I'll go ahead and stop here, but I'll select the simulation. It should go through, and it's basically running that simulation again with the new position of the load as well as the angle and anything else I might have changed. I'm not going to go and go through this entire simulation. It looked like it took about 3 minutes previously, but I'll leave it there for now.